Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Center webinar. This is Bill Voorhees, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. So I'd like to start off our event today by thanking Databricks for sponsoring today's event. Databricks is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. Now, past webinars are available on demand at datasciencecentral.com, and if you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our data science community. Now, today's webinar is entitled An Expert's Guide to Apache Spark, and that's going to be presented by Databricks. But before we begin, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We have two presenters who I'll introduce in just a minute. There'll be 10 to 15 minutes of Q&A following the presentation, and today's event is being recorded and will be available on datasciencecentral.com later this afternoon following today's live event. Now, I'd also like to encourage our attendees to provide questions throughout the presentation, as we'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. Well, I'm very pleased to introduce today's speakers, Bill Chambers and Matei Zaharia, both with Databricks. Now, Bill is currently a product manager at Databricks, where he leads internal data science initiatives and Spark-related product development. He's also the lead author of Spark, the Definitive Guide for O'Reilly Press, and that was co-authored with Matei. Now, in the past, he created SparkTutorials.net as a way to teach others the basics of Apache Spark. Bill holds a master's in information management and systems from UC Berkeley. Now, Matei is co-founder and chief technologist at Databricks. Matei started the Spark project at UC Berkeley and serves as its vice president at the Apache Foundation. He's also an assistant professor of computer science at Stanford. Now, throughout his career, Matei has contributed to several other widely used open source projects, including Apache Mesos and Tachyon, Apache Hadoop, and key components of Spark such as MLlib, Spark Streaming, and Spark SQL. Matei has his PhD in computer science from UC Berkeley. So Bill, Matei, thanks for being with us today. We're looking forward to your presentation. So join Bill Chambers, author of the book Spark, the Definitive Guide, and Matei Zaharia, chief technologist and co-founder of Databricks and the original creator of Apache Spark, in today's Data Science Central webinar as they break down the basic operations and common functions of Spark and walk through sample use cases where Spark has helped accelerate AI innovation. In today's webinar, we'll cover a general overview of big data and Spark, expert guidance on how to use, deploy, and maintain Spark, the fundamentals of monitoring, tuning, and debugging Spark, and an exploration into machine learning techniques and scenarios for employing MLlib, Spark's scalable machine learning library. So Bill, with that, I'm going to turn it over to you. You can start as soon as you're ready to go.
Awesome. Thanks, Bill. With that, we can go ahead and get started. And as Bill had mentioned, this is an expert's guide to Apache Spark. To give a brief overview of the talk, we'll go through some basic introductions, talk a little bit about Databricks, talk a little bit about ourselves, talk a little bit about sort of some of the history of big data, as you can see there, and then we'll do some projections out into the future, and then we're going to share some sort of Databricks customer stories, but really I think that the same fundamental narrative holds for Apache Spark success stories as well. So with that, firstly, I want to mention that Spark and AI Summit is coming up in just a couple of weeks here for Spark Summit, and it's in San Francisco this year, and there are going to be a ton of attendees. There's a ton of fascinating tracks. It's going to be our biggest one yet, and we've got some awesome keynotes from Tesla, Apple, Capital One, Overstock, Matei himself, et cetera. And so it's going to be a really, really fun event. This will probably be my fourth one at this point, and I consistently find value And, even being one of the lucky co-authors of this book, I still find myself learning so much during these talks. And so with this code, you can save 20% to today. So with that, we'll jump to introductions. Now, really quickly, Databricks, our employer, is a company that's really focused on really accelerating innovation by unifying data and AI. And you're going to see a very similar theme both in the customer stories as well as with Spark itself. I think that unification is something that's really important to hone in on, and that will be a focus of this talk. Databricks has a number of customers across industries. You could say the same sort of about Apache Spark, but I think what really brings companies to Databricks is a lot of that sort of expert maintenance, just we take care of, right? And having written the book, we both understand the complexities in approaching sort of maintaining production level data science platforms. And so, these are a number of customers that have chosen Databricks to be able to take that on. And so, as Bill had mentioned, I guess my name is also Bill, and I'm with Matei, who will pick up in just a moment. And we've just recently finished Spark, the Definitive Guide. You can buy it online now. It's approximately 600 pages, and we're really going to dive into, in the book, we dive into a ton of depth about all really Spark has to offer. And as mentioned, we both currently work at Databricks and work really hard on enabling companies to focus on solving business problems as opposed to complex plumbing. And to sort of set the background for this talk, I want to talk a little bit about both of our sort of pasts. I originally studied history in undergrad. And so my perspective is really a focus on historical context, if you will, and trying to find those sort of repeated patterns that come up over and over again. And I think that this is something that really sort of allows Matei and I to work really well together, because I think Matei's focus in originally creating Spark was looking at the historical context and then trying to project forward with trends. And so both of us had studied at UC Berkeley, and yeah, I think with that sort of sets the general context of, how can we take the lessons of history and use them to better understand what might kind of happen going forward. And so really quickly, I want to start off with a quote here. And this is sort of by a philosopher. I guess who has the quote isn't particularly important, but it stands to show that those who cannot remember the past are condemned to repeat it. And more colloquially, we often hear the folks that do not study the past, but the same principle applies. And so with that, I'd like to start off with an incomplete and arguably biased history of big data, just to sort of understand how we kind of got to this point, why Spark came about in the first place, and then I'll hand it off to Matei to sort of echo some of those themes as well. So big data, sort of as it's typically defined, kind of came about in 2003 and 2004 with the publication of two papers from some folks at Google. There's the Google file system and then MapReduce. And together, this was sort of compute and storage. And the emphasis there was such that you're going to need to store lots and lots of information on many, many computers. And then you're going to need a set of APIs to actually compute on top of that information. And if you haven't gone back and read these papers, or if you didn't read them the first time around, I think it's really well worth it, especially from, I would say, the expert's perspective, to go back and really dive into these papers, because you're really going to get a better sense for, again, what it brought about Spark and how things might change in the future. And I think these papers were really identified as something quite powerful. And so Doug Cutting over at Cloudera, chief architect there, he started Hadoop. And I think, if you sort of look at the commits and that sort of thing, you can see that they come about in that 2003, 2004, 2005 range, right about the same time as the publication of those papers. And Hadoop really, I think you can even see here that it says, hey, we're going to sort of bring in the HDFS and MapReduce together. So really there's the open source parallel to these private sort of proprietary Google systems. And as I said, this is about 12 years ago. And when you fast forward to what's kind of happened to Hadoop now, you really see this vast explosion of different tools that are very single purpose, right? And it's something wherein, looking at this list of information or Hadoop-related projects, there are many, many different projects that sort of solve different slices of it, right? We've got Hive for SQL, we've got scripting with Pig, we've got streaming with Storm, we've got in-memory with Spark, we have, MapReduce in there for batch, et cetera. And I think one of the reasons for the genesis of Spark, which Matei will touch on in a moment, is simply that there is a lot of different tools here, and that's really hard for an individual to master. And being lucky enough to work with Matei on the book really taught me, an important and humbling lesson, which is, having just written this book on Spark, I can readily and will readily admit that there's still so much that I don't know about Spark, right? It's a fast-moving open source project, so there's simply a lot happening. How any company can go about and implement this many tools in any reasonable amount of time is frankly beyond me. And when I sort of go and look at these 37 different tools, there's really one key word that consistently jumps out at me, or when I talk about it with others, and that word is complex. And I don't even necessarily mean that in a negative or a positive way, whatever it may be. I simply mean that by definition, consisting of many different and connected parts. Reviewing that slide, you can see that there are just a ton of different tools that are all going to have to connect and take on different roles. And whenever that happens, you end up having to stitch together a lot of things that maybe weren't built to be stitched together. And I think really the key lesson from this collection of history is that the history of big data is really this history of complexity. And really, I think the companies that are successful are approaching the problem as, how can I best mitigate or control this complexity? How can I try and eliminate this complexity as much as possible? And now Matei is sort of going to talk about, how Spark has kind of changed this and really approached this problem. So Matei, why don't you take it away?
Yeah, thanks, Bill. So when we started the Spark project back at UC Berkeley, I was part of this research group, probably one of the earliest research groups in universities to look at these data center scale computing technologies. And we were seeing this explosion of different tools already in the open source Hadoop ecosystem, and even in the large companies like Google and Microsoft. They were just, they were publishing about all these different designs of distributed data processing tools that they're building. And we wanted to go in a different direction because we thought this is too complex for anyone except, a company with 10,000 engineers to use. So one of the things we were really inspired by is actually the evolution of other new technology areas where there's a new type of tool, and over time the space becomes complex, and then there's some solution to that. And one example of this is consumer electronics, especially mobile devices. So if you go back really early on and look at the first mobile devices, probably one of the most exciting ones is when people designed the first cellular phones. And these phones were bulky, they weren't easy to use, they were expensive, but they let you do something that you fundamentally couldn't do before, which is actually take phone calls, on the go while traveling and so on. And so people would use them, and there was nothing else they could do instead, and this category of a mobile device came up as something that people would want. And this is a little bit like the initial role of GFS and map pages. They let you do computations on these large sort of 1,000 nodes data centers where you just couldn't do it before with any other tool. So if you had these large data sets or large computations, you just couldn't do it, and having anything that tackles that problem would be great. But what happened in the consumer electronics field and in other similar fields as well is, as soon as this new category of tool became technically possible, people wanted to do other things in mobile devices as well. And people ended up building many other types of mobile devices. If you were around, in the early 2000s and in the 90s, you'll definitely remember these. So, making phone calls on the go was good. People maybe simplify the mobile phone a little, but that was that. But then, what if you want to take photos on the go? Well, you could have a portable camera. What if you wanted to listen to music on the go? You could have a Walkman. What if you wanted to write notes? You could have, a Palm Pilot. What if you wanted to play games or look at maps? There were all these devices, and inside they use similar technology, and they let you do these things. Now, of course, in practice, most people want to do many of these different things, and having lots of these devices to handle, to take care of, to maintain, to power up, and so on, is, of course, painful. So the evolution of this is actually that things converge back again to a unified device, such as a smartphone. And today, of course, some people will still have a couple of the other devices, but 90% of what you are doing with these different devices now can be done on a single unified device. And the really cool thing about the unified device is not only does it do the same functions, actually, it is arguably worse at individual functions than a specialized device. But it also enables new applications that you just couldn't do with only one of these or with just separate devices on their own. So super simple example of that is video messaging, or even sending a photo to your friend. So there were portable cameras before. You could shoot a video. There were portable phones, you could communicate with your friend, but there wasn't, the camera wasn't on the phone. So there was no way to have that application where you actually send, where you send your photo to your friend. And because we unified the functions in the same device, you can suddenly do that really easily. Other applications that are an example of this are things like Waze for getting traffic conditions. So there were portable GPSs that told you your location and remembered a map. There were, of course, phones and stuff like that for communicating. But again, these functions were not on the same device. So no one could have written the Waze application before they had a unified device for mobile computing. And this pattern of new technology and then separate instances of that and then convergence happens all over the place in the computer industry and in general in technology. Another really great example of that is actually computer networks. It used to be there were separate networks, and they still are, in some places for the telephone network, for television, getting television in your home, for the internet and so on. And today, actually, most of these functions happen over the internet at their core, even though maybe the line to your house is still some other kind of network. Inside, it all gets converted to IP, and it just runs over the internet. There's, again, really important benefits to that for everyone involved, including, they can just invest in one technology and support all these functions. It's easier to allocate resources between them and so on. So that's the pattern we had seen before, and that's what we wanted to see whether we could make happen with distributed computing tools. So in Apache Spark, we designed the system from the beginning to be a unified analytics engine that lets you build complete data applications in the same programming model, so you don't have to go out and understand many different tools. That's one of the tenets of it. And initially, Spark was, of course, we designed it to do as well as possible in the different applications you want to do on top, like, say, streaming and SQL and machine learning. But in each case, maybe, there were certain things that it couldn't do that some of the specialized tools could do. But what we found is that over time, with relatively small extensions to Spark and just additional work in the libraries, you were actually able to match both the functionality and the performance of the specialized tools. And then by having this unified engine, it really simplifies things for users. So it becomes much easier to build and deploy applications. And it also enables these new applications that you couldn't do with the separate tools before. For example, streaming SQL or streaming machine learning, or using machine learning functions in your SQL engine. These are all very useful things for doing data analysis, and you couldn't do it if you had, just an awesome streaming engine on its own, or an awesome SQL engine on its own, like the ones that existed in the Hadoop ecosystem. So this is one of the tenets. And the interesting thing, if you look at a technical level of how Spark did this, and we talk about this in the book, it's not a particularly complicated engine internally. It still has maps and reducers similar to MapReduce. The main new concept it adds is a way to do data sharing through these distributed data sets that you can use to hook together many steps, many map and reduce steps essentially, and to keep data around between them and reuse it efficiently. And it turns out that just adding that concept to the programming model was enough to make it extremely general and support these. So this is the first tenet, is the unified engine. And then the second tenet that we found is extremely useful is, even though the engine can do all these things underneath, users don't want to write all the algorithms themselves. So all the research papers and presentations early on systems like MapReduce were about how you can write, some machine learning algorithm in 100 lines of code. You can write, k-means clustering or some algorithm, and that's cool. But in reality, no user wants to write k-means clustering. Someone should write it once and put it in a library, and then other people just want to call that library. And same with the other engines. So we also designed Spark beyond the engine as an open source project to have really good high-level standard libraries and user-friendly APIs. So the bulk of the code in Apache Spark today is actually in the libraries on top of it, and these are all designed to work together. So you can, for example, load data using SQL and then apply machine learning to it, or do a streaming computation and call your machine learning code in that, and so on. And that's where most of the action in the community is expanding these high-level libraries. So that's a kind of one slide overview of what is different about Apache Spark and how it is able to do this unification. And what we found since the project started is that this actually resonated very well with big data users. And I would also say that because Spark simplified the process of using big data so much, it actually brought a new set of users that would not have had the time or patience to use the previous tools, but that can now actually do large-scale machine learning and data processing using Spark. So the main reason for that is because it unifies these functions. It lets you use one high-level API to build an end-to-end pipeline that will all scale underneath. So just as a few sort of data points, the project actually first became open source in 2010, so it's about 8 years ago, and it's still growing very quickly. If you look at the number of meetup members worldwide, the number of open source packages that plug into it, and so on, those are still growing by a substantial fraction every year. And it's definitely ahead of every other open source project in this space in terms of user interest, active contributors, and so on. The developers, one of the main things that they always say they like is the APIs. And in the open source project, we've been very careful to keep the system forward compatible and really respect the users in the sense of if you write code on it today, we want the same code to continue working, 2, 5, maybe 10 years from now. And we don't want to just break stuff underneath you. So the project is very conservative about that, but it means that these APIs can stay for a long time. And you can actually build these applications that will continue running in production in the future. And it's also become adopted, started from this little research project at UC Berkeley, and it was gradually adopted first by smaller tech company startups and eventually by essentially all of the large tech companies in the space. Facebook, Microsoft, Amazon, Google, all of them use Spark internally or have external products based on Spark. So the other thing I want to mention with this is we, initially Spark focused primarily on the big data processing use case and machine learning. These were the two initial things we did, transforming large data sets and then passing them to a machine learning library. But over time, the project has also grown to cover other areas. And these areas also, even though at first they look different, it turns out that it's possible to run them on this unified engine, and then you get all these benefits, the network effects of having, single API where you can combine this with the other stuff. So in the past 4 years, actually, a lot of new libraries have been added over Apache Spark. So in 2014, we added data frames, which is a very popular concept for data science. I think most people starting with Spark today end up using that. We added an improved version of streaming called structured streaming that includes the benefits of Spark SQL and includes a low latency continuous processing mode that basically means there's no performance trade-off between using Spark versus a traditional streaming engine. And we added a graph analytics library called Graph Frames that combines graph analysis with SQL to give you a very powerful query language for that. So we think these and other functions that are coming up can live within the Spark programming model, and that there's value in continuing to add to these libraries. So to summarize, if you look at the open source project, and if you look at the way we are, we explain how to use Spark in the book. The main benefit is that Apache Spark simplifies the process of building these data-intensive applications. So you can focus on those applications. And if you look through the book, we've organized the book so you can actually beyond an intro section that says the basic concepts, you can kind of jump into any chapter later on and go to, say, machine learning or graph processing or streaming and start doing that work without having to go into all the other ones. And it'll still tie back, and it'll, you'll understand how to use it in the context of the whole engine. So that's what I wanted to say about this concept of unification and the way Spark does it, which is basically by allowing you to efficiently compose these high-level libraries. So in the kind of second half of the webinar, Bill is going to go through a few examples from some Databricks customers on how Spark simplifies different tasks.
Thanks, Matei. That was great, as usual. Yeah, so I think to sort of repeat and echo that a little bit, right? Spark is this general purpose engine, right? And so it does these general purpose things really well. But with this sort of library approach, that's where we see, frankly, what is the expert's guide to Apache Spark is to leverage as much as you can inside of Spark itself, because it's all about simplifying. Basically, once you kind of get the basics, you can jump anywhere. And that's exactly what we see across, frankly, our customer base. And so this first customer, Overstock.com, is this premier online destination for furniture and home decor. It's super popular, and really naturally they want to have a personalized experience based on a user's propensity to purchase to drive conversion and customer lifetime value. And the really problem set there is that they've got a massive number of customers, and it's challenging sort of convert those, right? How do you know that you're sort of speaking to the customer in the right way, in a way that's actually appealing to what the customer kind of values, right? And so you'll see stuff like high bounce rate, building out ETL pipelines being very resource intensive, data science focused on DevOps, which I think is something that's super common, where that transition from ETL to data science ends up being really, really challenging. And then you've got all these differing skill sets. If you jump back to that Hadoop slide where I was talking about before, you have all these different skill sets and all these different tools, and it's really difficult to collaborate. And so, when Overstock started really leveraging Spark on Databricks, they ended up having a much lower cost of basically moving models to production. And it also became a lot faster to deploy in models, right? Rather than stitching together multiple tools, they end up just using one tool to kind of be successful and cover the vast majority of their use cases. Also, they were able to sort of work together and really efficiently be able to leverage cloud resources and really collaborate across those different functions to kind of be successful. And I think the core vein here is that Spark allowed them to do all of this, each of these different functions, using one toolkit. So people weren't speaking different languages anymore. They were focused on that one successful tool to build out at any scale. And it's worth echoing, too, that we've got this whole machine learning section inside of the book. And that is something that, you end up seeing how to kind of leverage these different tools, how to leverage them within a general sort of Spark pipeline to be successful. And, basically Spark also has greatly simplified streaming. Matei touched upon it with the new streaming engine, structured streaming. And I had the total honor of basically helping be the product manager and guiding our developments there. And one thing that I saw consistently is that it was so easy to get started with structured streaming and build real-time data pipelines with basically no streaming experience. And if you look at the chapters in the book, you're going to see that same exact theme, where it's the same batch APIs, basically. It just sort of streamifies them for you. And that's what we saw with Viacom. Really the business use case here is driving customer retention and improving their service, right? Identifying challenges with video quality and, identifying business opportunities to increase engagement. And one of the challenges they had is that they were sort of suffering on the user experience end, and they didn't necessarily know it, or they would know it way after the fact, right? And then another opportunity was seeing all of these conversations in the audience and really trying to better understand their own programming to just make themselves better. And lastly, advertising suffered as well in order to actually try and understand and interact with their audience. And so basically, it was probably, a couple of years ago at this point, they sort of decided to dabble with this new streaming engine, structured streaming. And they were able to really get up and running in basically no time at all. And the benefits of basically leveraging Spark, which was already something that they had been using to build batch ETL pipelines, was that converting that over to a streaming pipeline was trivial. And what happened there is that actually reduced the video start delay by 33%. So they were able to predict trends and streaming issues, sort of video buffering issues, to provide that better viewing experience. Naturally, this increased customer retention and also helped them guide some of their engagement strategies to be able to interact with the audience sort of where they're actually at. And lastly, that sort of results in that business outcome of increasing ad conversions as well. And I think really what Viacom found to be true is that choosing this unified engine ended up being a huge benefit for them, because now it all has the same basic principles, and then you just apply them to different problem sets, be it ML, be it streaming, or be it graph analytics. And so Matei talked about graph frames as this powerful toolkit that allows for sort of SQL on top of graphs. And it's been a very, very powerful and frankly popular toolkit. We've got a chapter about it in the book. And I think one of the really powerful concepts here is that it makes graph analysis quite trivial to run. And many problems, as I imagine folks on the webinar are familiar with, can be pretty well modeled as graph problems, right? Where something like, if you're an Uber, right, then you're going to be sort of looking at trips and destinations and where a trip starts and where a trip ends. And so one thing that's really nice about graph frames is that, as Matei said, it's that standard library approach. And so it's something that users that already understand Spark can go ahead and effectively leverage. And so that's what we've seen within our customer base as well. And so I want to talk about this customer Shell, where they're looking at optimizing global inventory management. And the business case there is really trying to improve management efficiencies of the global inventory of drilling machinery parts, right? Since each sort of oil rig is a highly tuned machine, and any problems there are of immense consequence, not only for necessarily the company, but also for the environment, right? And so really understanding their warehouse inventory levels, forecasting, safety stock levels and really keeping people safe, and then predicting maintenance issues is of huge consequence for Shell and other oil and natural gas companies. And so, naturally you could try and pick a sort of single purpose tool to try and solve that problem. But the challenge there is that sometimes it can't operate at sort of the scale, right? And so the scale necessary to track all of that information. And that can lead to lacked visibility into different location of different parts where things kind of fall apart at the seams, like we've talked about once or twice before. Additionally, because you might just use a single system to track and then another one to try and predict when something needs to be resupplied, that can lead to an inability to actually predict when stock parts need to be, or parts need to be restocked. And so that causes operational delays and downtime. And I think that's a perfect example to just really quickly review, I think, Matei's great point about the motivation for Spark originally. That's when you're trying to use a single purpose tool and then interact with another single purpose tool, right? And it ends up just not really working. And so that's something that we've seen consistently and really came up in this particular example. And so lastly, I think, using sometimes single purpose for a very unique use case can end up being sort of, I guess this is the MapReduce example, where data processing ends up being quite slow. And so you can't react effectively and really quickly to changes in sort of stock parts, right? So if a warehouse has a large shift in a given day, which might happen, you need a system that's going to be able to give you the capability of reacting quickly. And so what Shell was able to do is really leverage the Databricks and Spark to perform this distributed data processing at scale and predict allocation and planning of inventory by kind of understanding this graph a little bit better. And so they were able to save millions per year by increasing this operational efficiency. And not only that, but also just deliver a better service and make sure that the machine is operating really well. And so as a benefit of leveraging Spark too is that they were able to get a much faster sort of performance speed up simply by switching to Spark on Databricks itself. And with that, those performance gains really accelerated the time to value and allowed the business to really focus on trying to solve the root cause of the problem, as opposed to trying to tune a cluster to make sure that you get an answer on time or something like that. And with this, really wanted to just echo that sentiment, right? Where what we've seen and what we see with our customers, our hundreds of customers, is that big data is naturally complex. And really trying to avoid that complexity as much as possible is what will make you and your company and the use cases that you want to actually succeed. Mitigating that complexity is basically always a good idea, and it's definitely a really good place to start. I think one thing that's always awesome for me as somebody that has the opportunity to work with somebody like Matei is that when he was sort of speaking just earlier in this webinar, he mentioned, hey, sometimes a single purpose tool is absolutely going to be able to do things that a general purpose tool won't. That's always going to be the case. However, that comes also at a trade-off of expertise, manpower, understanding, time, and even cost. And adopting a general purpose tool provides an immense amount of flexibility to those that are actually sort of operating, right? Those that are actually doing the work. And we really strongly believe that mitigating that complexity as early on as possible, at least to test it out, ends up reducing a lot of operational risk. And so that leads to, this kind of prediction where history really repeats itself, right? And things are always going to become faster, they're always going to become easier to use. But more importantly, this unification ends up being of immense consequence, right? So we saw Hadoop, this first distributed data processing engine, and now we've seen this sort of huge blossoming of specialized data processing engines where they solve a narrow set of the problem, right? But from there, that's where we see that unified analytics engine end up taking a lion's share of the workloads simply because it allows users to reuse their knowledge and be as effective as possible at trying to solve business problems really quickly. And so with that, really the future should be simple. And that, I think, is really, in a nutshell, what the Spark project is trying to do, is simplifying your ability to try and do multiple things with a single toolkit. That is something, that's really the thesis of the expert's guide to Apache Spark, is manage your complexity and try it with the tool that you already have and the tool that you already know is extremely successful. And with that, you're going to reduce the operational overhead because you already know how to run that given tool. And with that, you're going to be able to focus on the business problem because you're already familiar with the tool and how it works. And at Databricks, our focus there is building out this sort of unified analytics platform, really combining data with artificial intelligence and machine learning in order to basically have the operational, I need to move this data around to new locations, and then on the other side, actually being able to get business value and drive superior customer experiences for my customers, as someone that consumes Databricks. And so with that, I think our focus at Databricks as we stated in the beginning, is really a focus on accelerating innovation on behalf of our clients. And so what we provide is this unified analytics platform. Naturally, you'll have your own data sources, right? You'll have data warehouses, cloud storage, streaming data, possibly even Hadoop. Then, we provide this managed cloud service that means no tuning of clusters. All of that comes out of the box. Then on top of that sits the Databricks runtime, which provides performance and reliability and scalability of, effectively our variation of Apache Spark clusters. And then we have this collaborative workspace that allows for that sort of collaborative experience for everywhere from data engineers to data scientists. And all of this wrapped up is naturally secured to allow you, again, to focus on business problems. And at the heart of Databricks, and particularly the Databricks runtime, is Apache Spark, right? It's a super powerful toolkit. It's just kind of lacking, that workspace. Sometimes there can be challenges in operationalizing or running your own clusters or securing them. And that's really what Databricks' focus is allowing customers to leverage that tool in the most effective way. And lastly, we want to mention that we have some additional resources for you. We have a couple quick links. You can follow them once we publish the webinar slides. And these are just a couple of quick ebooks that provide some particular guides to Apache Spark. And these are taken directly from the book, more or less. And so really they're sort of catered for the things that you really basically need to know. And then from there, you can purchase the book to actually be able to dive deeper into those particular use cases. And I think if you review the particular webinar that we've had here and review the table of contents of the book, what we've really tried to do here is allow you to get a lot of value for the general case in the first part of the book, and then be able to dive into each individual section to learn about machine learning or graph analysis or clustering or streaming or whatever it may be. And that, I think, is the thesis for why Spark is so popular. It allows you to do so much with so little. And with that, thank you all. You can download the first 5 chapters of the book at this address, and I'll hand it over to you, Bill.
Hey, Bill, Matei, thank you so much for that excellent presentation. So we'll get started with today's Q&A session, and I want to thank the audience for their participation. We had a lot of questions, very good questions that have come in during the presentation, and we'll do our best to get through all of them in the time remaining. So during this Q&A session, I'll leave up this screen with contact information for Bill and Matei if you'd like to contact them following today's event. So let's get started. Bill, Matei, the audience is looking toward the future here. You talked about everything getting more simple. How do you think Spark will continue to evolve, especially around the trends of combining deep learning and AI?
Okay, so I can talk about that. So there's actually quite a bit of work in the open source community for deep learning on Apache Spark, and a lot of it is actually to plug in deep learning as a component in machine learning pipeline, which is the concept in the Spark MLlib library for machine learning. So you can combine deep learning with existing algorithms and with an existing data pipeline and use it in there. So one of the projects that we started at Databricks is called Deep Learning Pipelines, and it lets you use TensorFlow and Keras models with Spark at scale and apply them inside a pipeline. And there are also additional projects. There's a TensorFlow on Spark project that launches distributed TensorFlow on the cluster and lets you feed data into it from Spark. In TensorFlow itself, there's actually a connector to Spark that lets you get data into it. And there's a big DL project from Intel that lets you run deep learning on CPU clusters, which is where a lot of existing sort of Hadoop and Spark installations are. And you can still get pretty good speed ups by running that on a cluster. So my feeling is this: it's one type of tool that you want to combine with data processing and with streaming and batch inference after you've trained the model. So from the perspective of the rest of the stack, it will look similar to the existing ML algorithms.
Well, thank you for that explanation. Now, specifically regarding machine learning and AI, so what is the preferred library for machine learning in Databricks? Is it MLlib? Is it Spark ML? And what are your plans for expanding MLlib going forward?
Yeah, you can use so in Spark there's basically the Spark ML library is the sort of the newest and highest level library for machine learning, and that's what most people use. There's a slightly older set of APIs that are in a different package, the MLlib package, that you can also call directly, but usually you can just call them through Spark ML. But beyond that, there are also a lot of interesting ones in the community, and most people will end up using a mix of these, and we want to make it really easy to use these. So I mentioned all the TensorFlow ones. There's a great library for NLP as well, if you look for Spark NLP, and there's a variety of other ones as well. There's the XGBoost integration for decision trees. So really the goal is to let people use a mix, and we actually have instructions and easily packaged images on Databricks that have all the most common ones installed, so it's easy to call them.
Well, thank you. That was excellent. Now, kind of a simple technical question. The audience is wondering, in the Databricks Community Edition, is this basically working on Jupyter notebooks, or is it a Databricks notebook, or is it some third thing?
Matei, I can take that one. So Databricks Community Edition, I guess for those that don't know, Databricks Community Edition is just a free version of effectively Databricks, obviously a very small scale one that anyone can sign up and use in order to learn and experiment with Apache Spark. And Databricks Community Edition, and just Databricks in general, leverages a special kind of Databricks notebook that's deeply integrated with Spark. That allows us to do some nice things like show the progress of jobs, et cetera. What's nice about these Databricks notebooks is that you can export them to a Jupyter notebook. But under the hood, we've really implemented our own variation of the notebook that allows it to kind of be unified with Spark and allow us to provide more information to the users about what's happening with their particular Spark job. And so Community Edition, you can just sign up on the Databricks website. When you sign up for Community Edition, you're going to get access to a free small cluster that allows you to learn and experiment with Spark. And actually, a funny comment about Community Edition is that Matei and I actually wrote the entire book inside of Community Edition because we leveraged the collaborative platform to be able to work together. Naturally, the book is written in 3 different languages, Scala, Python, as well as SQL. And so to be able to take advantage of all of those different languages, make sure that all the code snippets run and whatnot, we had to have a really convenient platform. And so we wrote it all inside of Community Edition. So you're going to get really a lot of power and a lot of utility out of that particular toolkit. And so, yeah, that should answer the question a little bit more.
Well, Bill, that's a terrific answer, and it gets us more than halfway to the next question, because any number of audience members have asked, how do I get started learning, experimenting, prototyping, and obviously Community Edition is part of that. I noticed in your introduction that you had written some tutorials around this, but maybe you'd like to speak a little bit more about how people should get started learning. Are there MOOCs? Are there courses that you would recommend? What's a good curriculum or a course of action for getting started?
Absolutely. No, that's a great collection of questions, and I naturally empathize with the audience. I think when I started Spark tutorials, it's probably 3 or 4 years ago at this point, I kind of found an absence of a number of ways of learning Spark. That was a challenge for me when I was sort of pursuing this kind of data scientist role and career. And so in doing so, I really realized that absence, and that's why I ended up starting that website, just to sort of, help others learn what I had learned, and that's what really guided me to being able to participate in the book. Matei and I were sort of speaking and realized that, hey, we really need to have this definitive resource that's totally up to date with the Spark project, and that is very much the definitive guide. And so I would really recommend that you buy a copy of the book and leverage that, right? The first, 60 pages or so are just full of those fundamental core concepts. Regarding questions about sort of MOOCs and that sort of thing, at Spark and AI Summit are some great training classes. I took one probably 4 years ago when I was first getting started. And so those training classes are hosted and provided by Databricks, and we're going to cover all of the valuable information in those. There's everything from Spark tuning to doing TensorFlow and MLlib, et cetera. So those are really great ways to learn as well. Regarding MOOCs and sort of massive open online courses, that's something that we're really taking a second look at to better understand how we can better provide value there, right? Databricks had run some variation of those in the past, and really what we've kind of tried to pivot to a little bit is to provide, a little bit more self-paced training. And so on the Databricks website, you can find self-paced training that allows you to kind of get those basics. And with those, there's also a training course to get Apache Spark certified, which is definitely something that you should do, and that'll be all on Spark 2.0. Obviously, the book is a great resource for that, but as is the self-paced training. And so those are some of the best resources at this point to really get started and learn. But yeah, I guess that's about it.
Well, Bill, thanks for that terrific answer. And we have time for one more question, I think, and I just want to make sure the audience has a little confusion over the difference between open source Spark and Databricks. And I know you had a good slide on this back around, I don't know, number 43 or so. But we hear so often, oh, well, I'm going to use Spark, I'll just get that on AWS. Would you reinforce for us what is the difference between using Spark with Databricks and open source Spark?
Yeah, definitely. I think really the key here is that the Databricks runtime is really just Apache Spark, but really tuned by the original creators, right? That's something that's really important point to understand, right? Folks like Matei, folks like Reynolds, folks like Michael Armbrust, et cetera, spend a lot of their time at Databricks just, how can we make this simpler? How can we make this easier? And so, open source Spark or Spark on sort of default cloud providers, whatever it may be, it's certainly a viable option for some, but, kind of like we've talked about throughout this presentation, what ends up being of immense consequence, just sort of jump back to this focus on innovation, right? Something that ends up being of immense consequence is tying all of these things together. And that's really where the Databricks runtime comes in. It's going to provide just automated performance, automated reliability, automated production jobs in a super simple turnkey way. And I would encourage everybody to just give Community Edition a try, because it's basically the same Spark. It's certainly the same APIs. It's just faster, smoother, and zero maintenance. And that's the fundamental value proposition for Databricks runtime and what we see over and over again. On top of that, I guess one thing that's also awesome about the Databricks runtime is we've tried to rough out some of the sharp edges, if you will, especially when it comes to running Spark in the cloud. And so we have these optimized connectors for running on top of these cloud services or connecting to cloud storage that allow you as a user to just know that this connector is going to work, right? You don't have to pull something off of GitHub and give it a try from there. We've got the certified ones that are super strong and production ready. And so that's really those are the biggest differences.
Well, Bill, Matei, hey, thank you so much for some great answers to some very good questions. And for those of you that asked questions today that weren't answered, we'll be sending all the unanswered questions to Bill and Matei and the Databricks team so they can follow up with you after today's event. Now, I have just a few quick announcements. If you'd please mark your calendars for May 24th, that's tomorrow. And that's our next DSC webinar, which will be Modern Data Science Workflows, to be sponsored by Looker. Also remember that today's taping will be available for on-demand viewing later today, and you can find that on the home page of Data Science Central in the Webinar tab, located at the top of the page. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions. A special thanks again to Databricks for their sponsorship, and particularly our speakers, Bill Chambers and Matei Zaharia, for their insights into today's topic. This is Bill Voorhees. I'm very pleased to have been your host for today's event. I look forward to seeing you all again tomorrow, May 24th. Have a great day.